Yesterday we kind of started talking about a mole, of course, and we know that a mole is like a really big number, 6.02 times 10 to the 23 of anything. Okay, you can have anything. Okay, it could be like this example here is if you took 6.02 times 10 to the 23 pennies and you stack them basically. It says here it'd reach from here to the sun and back over 4 million times. So quite a large number, of course. Atoms, molecules are very, very tiny. So we need to talk a lot about a lot of them to actually be able to weigh them. Okay, so we need to, if we want to weigh them, that is a substantial amount of particles, atoms, molecules, whatever. Okay, so it could be anything. All right. We talk about using the mole to count particles. Okay, and we said, hey, if you want to figure out this, yesterday we said you could cancel out units if you want, if you're happy with that. We can use ratio and proportions, or like I said, what you guys call equivalent fractions. Okay, that's fine too, and maybe that's kind of what we need to do. I don't know, but I gave you this example yesterday, and I said, this example with the eggs here said, a dozen eggs, of course, is 12, right? So we know that 1 dozen eggs, 1 dozen is 12 eggs. And their question was, in this case here, if I had 3 dozen, how many eggs would I have? So I said, hey, we can set up equivalent fractions, match up the units, of course, and solve for x here, right? So if 1 dozen is 12 eggs, then 3 dozen is how much? Okay. Now please know that you're doing the same thing as before, like when I showed you the first thing yesterday. You're setting up the fractions so that units cancel each other out. Look what happens when you cross multiply, guys. Remember, this would actually be eggs here. Yes, correct? Okay. Dozen, dozen, eggs, eggs. So look what happens if you actually write all this stuff out. You actually get the right answer with the correct units if you put this in the right spot. Look, 1 dozen times x eggs, yes, equals 12 eggs times 3 dozen, yes? Okay, so we cross multiply is what we said, yes? You guys know how to do that, correct? Okay, so that works, that's fine. That's a ratio, proportion, or equivalent fraction thing. So look what happens. Okay, I got 1 dozen, 1x basically, or just basically x, dozen, and I got eggs here. And on this side I got 12, well, let's do this. 36, right, 12 times 3, eggs, and dozen over here. Now, how do you get x by itself? Well, you divide both sides by, well, and in fact, this was 1x, right? If I want to solve for x, I mean, this kind of seems silly, but we divide by 1, yes, to get rid of the number out front. But look, if I get rid of dozen and eggs here, if I divide by dozen and eggs here, and I get rid of dozen and eggs here, basically, okay, and dozen here, x is, of course, 36. Yeah, you are going to be canceling out some of the units that go with that. Okay, some of the units go with that. Probably a little bit tougher for that one, but if you look at the next example that we had here, which was, let's see, maybe it was this one here, I guess. We did this one yesterday, okay? And this is an example of where you kind of flip the fraction over and you cancel out, like units kind of thing. So look, 3.6 moles. So moles cancels with moles and you're left with molecules, yes? Okay, so that's an option, of course. What I said yesterday is if you guys know equivalent fractions, then perhaps, I don't know, I guess it's up to you, but we have to remember that 1 mole, okay, 1 mole of anything, 1 mole is 6.02 times 10 to the 23, whatever you're trying to do, okay? So it might be eggs, pennies. In this case here, it says how many molecules, okay? How many molecules? So if 1 mole is 6.02 times 10 to the 23 molecules, how many would 3.6 moles be? Okay, basically, how many molecules would that work out to be? Okay, and then I said, hey, let's cross multiply and solve. 1 times x, right? And in fact, if you want, I mean, it's 1 mole, if you want to keep units the same, 1 mole times x, and 6.02 times 10 to the 23 molecules times 3.6 moles. Yes? Okay? And if you divide both sides by 1 mole, in other words, to get x by itself, I divide by 1 mole, right? Divide by 1 mole, and the moles will cancel, and basically you'll be left with molecules, yes? Okay? And I forget what the answer was for this one here, but of course my answer will be in molecules. And what was 6.02 times 10 to the 23? Let's get the big calculator out here. Okay, what do we got here? 6.02. I always just do it like this, guys, but it's up to you, like I said. 6.02 times 10 to the 23, okay? If you got one of these. If you don't have one of these, then you're kind of a little bit on your own. You're probably going to have to type some numbers in and make sure you figure out, you know, get the right answer kind of thing. Times 3.6, right? That times that. So times 3.6, and I get 2.167. 2.167 times 10 to the 24 molecules. Okay, as your answer. Good? Yeah? The second example we had, okay, so we did that yesterday. The second one that we had was this one here. Once again, it talks about how many formula units are in 25 moles of magnesium nitrate. Okay? Now, once again, they're talking about how many, basically, when they say formula units, that's another word for saying basically how many compounds of magnesium nitrate would there be? How many MgNO3s would there be? Kind of thing. Brackets 2. So, we know that 1 mole, right? We're always going to start with this, guys. 6.02 times 10 to the 23 molecules. In this case, you might want to say, instead of molecules, maybe you want to say formula units there. Okay? Whatever, doesn't matter. Okay? And you have 25 moles. I'm going to put that up here. Remember we talked about yesterday. Apples, apples, oranges, oranges, right? We're going to compare them, equivalent, beside each other. Or Ferraris and Ferraris and Porsches and Porsches. Yes? Jacked up diesel, yeah? What's Honda Civic, yeah? Maybe I'll bring it down to your level. I don't know. Hey, maybe it is jacked, I don't know. Maybe it's Porsche, I don't know. Hey, good for you. It's not me, I'll tell you that. Okay, anyway, cross multiply and solve, yeah? So moles, molecules, your answer will be molecules, right? Or formula units, okay? Cross multiply and solve. 1 mole times x, basically, or 1 times x, or x, yes, is 6.02 times 10 to the 23 molecules times 25 moles. And if you wanted to solve for x, of course, we would divide both sides by 1 mole, yes? Get x by itself. So look what happens. If I take this, let's see, can I do that? No, I can't. Of course not. That'd be too easy. Okay, so let me do this. Divide by 1 mole, yes? Get rid of that 1 mole, and I'm going to put it over here, yes? So the moles will cancel, and I'll be left with molecules, of course, right? And even if you are not sure about that, you have to know that if we're doing moles to moles and molecules to molecules and we're missing X, it's molecules, yeah? So what's 6.02? Let me guess my calculator. Oh, no. 6.02 times, oops, sorry. 6.02 times 10 to the 23 times 25. And I get 1.505 times 10 to the 25. 1.505 times 10 to the 25. And that would, of course, be molecules, right? That makes sense. Molecules is a really big number, right? If I have 25 times those, I should get a really big number, right? I should always have lots and lots of molecules or atoms or ions and not as much moles, right? Okay. And the last one here, I don't know, remember if we got to this. Did we do this one or not? I don't think we got this quite this far. So let's do the last one here, and then we'll move on to the kind of the next lesson here. 14.3 moles of nitrogen gas. Okay, by the way, and it should be how many particles, yes, are in 14.3 moles of nitrogen gas. Nitrogen gas, just out of curiosity, because eventually we are gonna do this. What's the formula for nitrogen gas? N nitrogen, N2, right? N2. I have no brighter, clever friends, right? So we got to remember those, N2, okay? That won't play a factor in this. They're just basically asking us how many N2s do we have, okay? How many of these N2s do we have? And we have 14.3 moles. And I know, once again, and I told you guys yesterday, look, if you wanted to, how many particles? Okay, look, I'll put particles here. How many particles? Particles. Does it matter? I don't think so. Is 1 mole, yes. So 1 mole is 6.02 times 10 to the 23 particles of anything. You don't have to, you know, guys, you can flip the fraction over, right? It doesn't matter. But now, you just got to make sure that you match up the units, right? Where's 14.3 moles going to go? Top or bottom here? Top or bottom? Bottom, right? Moles, moles, yes? And let's solve for that in this case. That's what I'm missing, right? How many particles would that be? Good? Okay? That's all you need to be able to do, guys. Cross multiply and solve, right? I'm going to skip a little bit here. 1 times x is x, correct? 1 times x. And 6.02 times 10 to the 23 times 14.3. And if I do that, once again, I'll have to do that on the old calculator here. 6.02 times 10 to the 23 times 14.3. 8.6086 times 10 to the 24. By the way, we haven't really talked about significant digits, but I'll just tell you a little bit about that. You'll probably talk about that a little bit more down the road here. But look, how many numbers are here basically? Like, you know, in the question there's 14.3. How many numbers are those? 3? Yeah? Right? So usually what that means is we need to have 3 in my answer, okay? And there's a few other rules that go with it, but generally speaking, that's kind of the general rule here. So look, 8.6086. Well, I can't chop numbers off the front because the front numbers, of course, are the important ones, yes? Like 8.6, that kind of tells you where the decimal is and stuff like that. So I'd say 8.6086. Let me write that down here. 8.0. I forgot it now. No, 8.6, sorry. 6086 times 10 to the 24. That's all right? Yeah. Okay. So if you want to use kind of thing, or you want to record your answer appropriately, we talk about significant digits. Significant digits are the following. So look, there's 3 digits there, yes? 3 numbers, just like in my question, 14.3, there's 3 numbers. There's 3 numbers there. So usually we'd round those 3 numbers appropriately up or down, okay? So if you really want the correct answer here, we'd probably say 8.61, because this number is bigger than 5, yes? So we'd round up times 10 to the 24, and this would, of course, be particles in this case. because they want to know how many particles, right? And that's what we put in the equation. Basically, 1 mole is 6.02 times 10 to the 23 particles. All right? Good? Okay. So that, like I said, that was kind of what we did yesterday up until that point there. Today, we are going to do one more quick little lesson here, kind of exactly the same stuff, guys. And then we'll give you some time to do some questions here. So let me just find that here real quick. Continuing on, guys. Like I said, and actually there's a few examples here that are just kind of repeats as well here, but we'll talk about that. So once again, we want to talk about Avogadro's number and relate that to moles and molecules kind of thing. So there's a few more examples here for you. We did this one on the previous one already, right? 3.6 moles. And we did this one as well, and we did the nitrogen gas, okay? Make sure your answer makes sense as well, right? So if we're talking about particles or atoms or like individual molecules, atoms, compounds, formula units, things like that, the number should be quite large. If we're talking about moles, it may not be quite as large, of course, right? So here we go. Let's take a look at this one here. This will be about the 4th slide in there, guys, or a 5th one or something like that. So find that one for yourselves. Okay. So like I said, this will be about the, I don't know what. Yeah, bottom of page 2 there, yeah. Okay. So bottom of page 2. Converting number of particles to moles. Okay. So now, this is kind of the opposite in sometimes. So we have to be able to do both. So it's important, like I said, that we always start with the ratio and we know where we're putting numbers, okay? So it says here, people sometimes take magnesium hydroxide to settle an upset stomach. So when you take Tums or, what's the other one? Yeah, Pepto-Bismol. What, I'm thinking of the other one. Yeah, a little bit, yeah. What's the other one? Not Tums. What's the other one? Rolaids, yeah, Rolaids, okay? You are basically taking some base, and the base basically, you know, settles down the acid in your stomach. You have a hydrochloric acid in your stomach, basically. All right? So it says here, if a teaspoon of this medicine contains 4.1 times 10 to the 21 formula units, okay? Formula units are basically molecules or compounds, they would say, of magnesium hydroxide. What amount in moles of magnesium hydroxide is in the teaspoon? Okay, so with these questions, you see we're kind of talking about formula units or molecules or compounds. We have a lot, don't we? Okay, we have 4.1 times 10 to the 21. What amount in moles? So what amount in moles is the question here. We are always going to start with the same ratio for these questions. We're going to say, okay, well look, I know this. 1 mole of anything is going to be 6.02 times 10 to the 23. In this case, it says formula units, yes? Formula units. Okay? Good so far? Yes? So what I want you guys, look, don't tell me I don't know where to start. You start here, okay? You have to, because that's the ratio we know. We know that 1 mole, we know a dozen eggs is 12, right? So we write it down. We know this, okay? A dozen eggs is only going to help you if you're on the farm, right? Or you're at the grocery store. We're talking about chemistry here. So in chemistry, we always say 1 mole is 6.02 times 10 to the 23 molecules, formula units, compounds, whatever, okay? Now look, it says a teaspoon of medicine has 4.1 times 10 to the 21 formula units. So 4.1 times 10 to the 21 formula units, where does that need to go? Top or bottom of my fraction here? And just I want you to think about that for a second. 4.1 times 10 to the 21 formula units goes top or bottom? Katie? Bottom. Absolutely. Look, formula units, 4.1 times 10 to the 21 formula units. Let me ask you this. Does that make sense? Look, What's the question asking you? What amount in moles? What's the amount in moles? What's this? Moles? When I solve, am I going to get my answer in moles? Yeah. So I guess that probably is good, isn't it? Now, here's the tricky part with this, though. Okay? Yesterday, we just cross-multiplied and solved, and it was boom, done. Right? But now you got to pay a little closer attention here. Now, look. When I cross-multiply, now you might say, I'm going to take this times this. You can do that first. That's fine. No biggie. Or you can take this times this. Okay? But that's where cross-multiplying, yes? Still got to cross-multiply. But I'm going to write this one down first. It doesn't matter, guys. But look, 6.02 times 10 to the 23 times x. Yes? Good so far? Cross multiply, just like you did on the last sheet. The last ones. Good so far. Okay? So this times this. And 1 times this. So 1 times 4.1 times 10 to the 21. Okay? Good so far? We're still cross multiplying. We're doing exactly the same thing we did on the other ones. How do I get x by itself? So how do I get like x equals something? What do I need to do? Let me ask you this. Now that's kind of, those are silly numbers, right? But look, if you had 4 times x equals 8 times 2, how would you get x by itself? What would you do? It's 4 times x, what do you need to do? Nope. Yep. Divide by 4. So I divide by 4, because 4 divided by 4 is 1, yes? Okay? But what I do to this side, we know we've done fractions before at some point in time in your life, whether you like them or not. If you divide this side by 4, don't you have to divide this side by 4 to keep the two sides equal? Right? You can't just do one side and be like, ah, good enough, because you'd be changing the other equivalent fraction part. Okay? So look, if that's the case, how am I going to get x by itself right here? I'm going to divide by 6.02 times 10 to the 23. Yes? Wouldn't I? Because if I divide, that's going to be 1, isn't it? So now I have 1x. And I'm going to also divide this by 6.02 times 10 to the 23. And look, when I do that, that's 1x. And on that side, I have 1 times 4.1 times 10 to 21 over 6.02 times 10 to the 23. Yes? And there you go. If you can divide that on a calculator, you can get the right answer. Okay? Here's the tricky part. Okay? You have to make sure you divide it properly. So you guys go ahead and do that. And I'm going to do it too. But I got to go turn my calculator back on because mine turns off after a while. Okay? So, once again, guys, you need to make sure you bring a calculator. Okay? I don't know what kind of calculator you have. If you're using a phone, good luck on you. No offense, but I don't know how to work that. If you use this, I can help you. If you don't use this, then I can't really help you. I can kind of give you a ballpark, but you have to be careful. Okay, and like different ones you put them in differently, so and there's so many different versions. So to divide this, you should do the following. Okay, 4.1. Now, I guess before I start here, you have to make sure that whether you have this calculator here or a version of this, or you have a phone or whatever, I don't know. But you got to make sure that you're doing the correct order of operation. That's the biggest thing here. Okay? So, basically, what I'm trying to tell you is this, and you can do this however you want, but just pay attention for a second. it has to be this entire number. It's 4.1 times 10 to the 21, so it's a lot of zeros after it. It's a huge number. It has to be this number divided by this number, if that makes sense. Okay? And there's different ways of entering the number, but I'm going to tell you, okay, how I do it is I just take this number here and enter it, no biggie. But when I go to divide by this number, I put brackets around it. Okay? Now there's a way to get around that as well. If you use the E button, if you got the E button, you can use the E button, and that sometimes will fix that for you. But you have to enter it properly. And the most important thing is we check the answer right now. Okay? So if you don't get this answer, then we're not entering it properly, basically. So, you know, if you want to use brackets, guys, you can. Okay, brackets, right? Divided by 6.02 times 10 to the 23. You definitely need brackets on the second number, though. You need to have brackets, or you need to enter it as an E. Okay, this should be your answer. 0.0068. Okay. If it is not, then like I said, make sure that at least the second number here, 6.02 times 10 to the 23, has brackets around it. Okay? So however you do that, that's up to you, but that's the number you need to come up with. So I'm just going to write that down here. It's 0.006810. And of course, don't forget, guys, we need to have units there. It should be moles, yes? Because that was the question, right? I said, hey, if we got 4.1 times 10 to the 21 formula units, what's the amount in moles? Well, it's 0.006810. Okay? Good? Now listen, if you do not use brackets, you'll get a ridiculously large number, because what happens is, and don't do this obviously, I'll tell you the number. If you see this number, guys, I'll tell you right now, it's an order of operation thing. So divided by 6. Okay. So look, if you don't use brackets, you get 6.810. Okay, so same kind of deal, but look, times 10 to the 43. Okay, that would mean you'd have like 41 zeros. Okay, at the end of this number, 41, okay? And I know you're thinking, well, 21 is kind of ridiculous too. It is. But if you ever see this, okay, I'm telling you, if you ever see E43, E42, E45, 41, anything like that, it's not right, okay? It is not right. It is a bracket issue, okay? That's what it is. It can't be that big. Okay, your biggest number that you'll ever probably get is, it's times 10 to the 23, probably like 25, 26, 27. Those are legit numbers. Anything past that, I'd say probably not. Okay, yeah. Yeah. Okay, is that good? Clear? Okay, make sure you get that number. It should be 0.006810. Hey, and you know what? We could even do scientific notation, can't we? Let's do scientific notation for a little practice here. Let's go a number between 1 and 10. What's that? Huh? 6.8 is a number between 1 and 10. Yes? Okay. And I need a power of 10. Yes? So if the decimal, basically they're saying, hey, the decimal's here. Which way should I be moving the decimal, left or right? Or what should I use, a negative or a positive? This number is less than 1, so I use a less than 1, so I use a negative, yes? So, if it was here, I'd have to go 1, 2, 3 to the left. So there you go. Okay? If you wanted to talk about significant digits. So look, in this question, how many significant digits do I have? In other words, what's the number, how many numbers do I have here? And the answer is I have only 2, right? Because the times 10 is just taking up a bunch of zeros, yeah? So I have 2 there, yes? So my answer should be 6.8 times 10 to the whatever. Hello? Yep. Okay. So 6.8 times 10 to the negative 3 moles may be the best answer for. Okay. I'm going to let you guys try this one here. Let's get you guys to do this one. So once again, you should have this on your sheet there, guys. And this number here, of course, is 4.50 times 10 to the 25, yes? Okay, molecules. So how many moles does it contain? So go ahead and try that one. Set up a ratio proportion, just like we've been doing. Okay, where are we starting? Always here, yeah? 1 mole. And we want to, it says how many, what? It says if a sample of this gas has 4.50 times 10 to the 25 molecules, so I'm going to put down molecules here. Okay. I have apparently, once again, so that's why I'm putting molecules there, because it says molecules, right, in the question. You know, if you want, you can put compounds. I don't think it really matters in the big scheme of things kind of thing. But if I had 4.50 times 10 to the 25 molecules, I want to put that on the bottom. Or, you know, if you flip this over, you got to flip that over, of course. We want to keep it the same. And quite often, guys, N actually represents the number of moles. Okay, so the letter N actually represents moles, just in so you're wondering, in case you're wondering. So cross multiply, okay, and basically I'd say, okay, well, 6.02 times 10 to the 23, you know, and if you want to use the units here, molecules times N gives me 1 mole times 4.50 times 10 to the 25 molecules. Okay. I would divide both sides by 6.02 times 10 to the 23 molecules. So I would say, okay, hey, how am I going to get N by itself, for basically the number of moles, is what that stands for. I divide by 6.02 times 10 to the 23 molecules. Okay. And I divide by, over here, 6.02 times 10 to the 23 molecules. So molecules cancels. I'm going to be left with moles, of course, and I need to divide those two, 4.50 times 10 to the 25 and times 10 to the 23 there. Okay, so to do that, my calculator's probably turned off, I imagine you. All right, so to do that, I need to, let's see here. Once again, there is a way to get around it, guys, and if you've used your calculator, you will know what it is, but you can just type that number in normally, because that's the whole number, divided by, if you're going to do it like this, you do need brackets here, always, always, always brackets here. Okay? And you get about 74.75 moles. Okay? 75 moles. Good? Yep. 74.75 moles. You must have typed in either I typed in the wrong number or you did. Yeah. Okay, good. All right. Now, once again, let's talk a little bit about significant digits, because ultimately I think that's probably important enough. We need to be able to do that. Is that good so far, though? 7508 there. Okay, so if you look over here, guys, let me get rid of the calculator here. So look back to the question here. How many significant digits do we have in the question? How many numbers do we have in the question, basically? And of course, the answer is, well, we don't worry about the times 10 to the 25, because that's just a bunch of zeros at the end. But I have 3 here, right? 4.50. So they're saying it's 4.50. It's pretty, you know, 4.50, that's how accurate it is, kind of thing. So here at the end, I should also have probably 3 numbers. And here I have actually 4, so we'd want to round up or down accordingly, okay? So 74.8 moles would probably be the best answer I could come up with, because 5 or above, we'd round it up, Yes? Okay, so we want to round the number at the very, very end. Okay? Good? All right, let's take a look at another one here. This should be 4.39. Oops. No, never mind. Okay. Let's go ahead and do this one here. So last one here, 2.64 times 10 to the 21 molecules. How many moles are in this sample? Sulfur is a very odorous element. How many moles are in this sample? Okay. And as always, right, we set up our ratio. Okay. I flipped them over this time. It doesn't matter. You flip yours over. It doesn't matter. Or don't. I don't care. But it doesn't matter which way you write this. But it does matter where we put the next number because we want to keep it lined up. Yes. So in this case here, look, it says I have a sample that contains that many molecules. So I'm going to use the word molecules in my little ratio here. 1 mole has to be 6.02 times 10 to the 23 molecules. Okay. I have 2.64 times 10 to the 21 molecules. Should I put that in the top here or the bottom? What do you think? Top or bottom? Top or bottom? Top. Yes? Okay, we want to keep it the same. So I'm going to put my 2.64 times 10 to the 21 molecules here. And once again, moles here. I'm just going to put an N there because N represents number of moles. Okay? That's just the letter we use. Okay? Cross multiply and solve, right? So you'll quickly see a pattern here. 6.02 times 10 to the 23 molecules times N, right? So that times that, and I'm going to multiply that by 1 mole, or set that equal to 1 mole, and and 2.64 times 10 to the 21 molecules. Okay? And once again, you want to get N by itself, so you want to divide 6.02 times 10 to the 23 molecules. That'll get rid of basically everything there. Okay? And I divide this side by 6.02 times 10 to the 23 molecules as well. N should be obviously 1 times 2.64 times 10 to the 21 divided by 6.02 times 10 to the 23. And you should get here, let's see, 2.64 times 10 to the 21 divided by 6. I believe it's 0.0043853, and of course your answer would be in moles because the molecules have canceled and you only have moles left. Is that what somebody else got too? 0.004385, yeah? Okay. Somebody else too? Sometimes I type the numbers in wrong or I get excited because it's math. Stuff happens. Good? Yes? Is that the okay? Significant digits, guys. So if we wanted to kind of go back to this question here, how many do I have here, significant digits in this question? I'd say probably 3, yeah? 2.64, right? So we have 3 numbers there basically representing this number. So I need to have 3 numbers representing this number down here, okay? Now, what I would suggest is, first of all, 3 numbers. Okay, the zeros in the front don't count as far as that goes because we could just rewrite this as scientific notation, which we're going to do actually. If I was going to rewrite this as scientific notation, I'd say 4.3853 times 10 to the what? 1, 2, 3 moles. Okay? And now I'd say, okay, the question had 3 significant digits. Let's have 3 here. So I'd say, okay, 3 is right there, 4.38. But this number is a 5, so let's go to 4.39 times 10 to the negative 3 moles. That would probably be your best answer there. Okay? The most important part right now, guys, is that we are able to get the right answer, like 0.0043855. Yes? Okay, we can work on the little things like scientific notation, and well, that's important too, but we need to, you know, as far as significant digits go, we can work on that kind of thing. Okay, we can work on that. All right. Okay. So, if you still find this confusing, you can use a formula. Okay. N is the number of individual particles, atoms, or even blueberries or pennies or whatever you want to call it. So that's the number of individual molecules or formula units or whatever. N is the number of moles, so that would be that. And Na is called Avogadro's number. Okay, it's a short note. So that's the 6.02 times 10 to the 23. Okay. So if you understand formulas better, maybe that's going to work for you instead of equivalent fractions or trying to cancel out formula or units or whatever. I don't know. Okay, you know, like I said, I think some practice would help. What you have to remember is there's 2 types of questions, right? So if I said, hey, we got 4.35 moles of something, okay? You need to know where that number is going to go and what operation you're going to be doing with that, right? So you will always, guys, and you might be like, well, I don't want to write this out every time, okay? Some of you guys maybe already know what the pattern is here, okay? You know, and if that's the case, great, good for you. And if you don't know what the pattern is or you don't know what you're doing, because I'll give you a little hint, you're either multiplying or dividing, okay? And if you're not sure, you better write this out, okay? Because guess what? This works every time. It does in grade 11 as well. Trust me, because I use in grade 11 too. No different. In fact, I use equivalent fractions all the time. Even in grade 12 chemistry, we use equivalent fractions. It works. Cross multiplying and solving, it works. Okay? So if you're not sure what's going on, we'll start with this every time. Write this step 1. Write this out. This is 4.35 moles. Where does that go? Here or here? Top or bottom? What do you think? Top. We got to keep the units the same, yes? So I put it on the top. Okay? This is more like a question from yesterday. And then I'd say, okay, well, what's that then, right? And I'd cross multiply and solve, right? Correct? 1 times x, x. Yes? This times this is your answer. Done. Right? Okay? So that's one option. Or the other option is, of course, we have what? 2.08 times 10 to the 21 molecules, let's say. Once again, look. And then you're not sure what to put here. You say, hey, what's the question say? It says molecules. Okay, put molecules. Right? Where does this number go? Top or bottom? Top or bottom? Top or bottom? Bottom, right? That's molecules. This is molecules down here. So I want to put 2.08 times 10 to the 21. And I want to solve for n, basically. Or you can put an x there, I guess, if you really want to, guys. But n is what we use to refer to moles. Cross multiply and solve. This one, you're not going to be able to just times. You got to divide. So you need brackets, etc., yes? Those are the 2 types of questions we're looking at, yeah? Okay? Good. All right, I'm going to be quiet now.